Okay, so let us start with the session. Last weekend, we have discussed about views, okay, as an object. So what is the purpose of view, how to create view, what are different uh, ways by which you can create different types of views, etc., etc., right? So now today we are going to start with a different topic of writing queries. Okay, the topic it belongs from the topic belongs from subqueries. The topic belongs from subqueries, and the name of the topic that we are going to talk about is called as derived tables. Okay, so what we are going to study right now is derived tables. Now let us understand what is this derived tables. Sometimes it is called as inline view. Okay, we have just studied views, and there is something called as inline view, but there is a big difference between inline view and a normal view. Fine. So what are these derived tables? Derived tables are the queries which are written in the from clause. Okay. So far we have seen subqueries in different parts. For example, we have seen subqueries like this. Select, let's say, ename and sal from employee, where salary is equal to, I may say, select max of sal from EMB, right? So this will give me name and salary of the person who is earning maximum salary. So we have used it in the where clause. We have also used a subquery in the having clause, isn't it? Like that. So we have used it at different places so far. You can use it in select also. But subqueries which are used in the from clause, they are called as inline view, or they are also called as derived tables, right? So that is the definition of derived tables. Now how to use them or when to use them. How to use them is not that difficult, but in what scenario should we use them, that is more important. So uh, they're called as derived tables, or they're also called as inline views. Okay, just a minute.
So, what is the difference between inline and derived? Inline inline views, and is there any relationship between inline views and derived table?
Inline view is another name of derived table. Okay. Now, what is the need of using derived table or the inline views, that we will have to find out. This is the example. When you have aggregate functions along with grouping columns, okay, then you need derived tables. AF is aggregate function, GC means groupable columns, and NGC means non-groupable column. So if in a query you have aggregate functions along with groupable column, the example is given here. For example, uh, the aggregate function is max of sal and the groupable column is department number. Now, this data, it's not available in any form in the form of a table. Do we have a table which contains such kind of data in our database? No, isn't it? There is no physical table which stores this data. So what I can do is, I want this records, maximum salary. There is no table in my database which holds this information, right? So if I want to run a query based on these records, then from where I'm going to get these records? I'm going to get these records through derived tables, right?
Mhm.
So this part I will be writing in the from clause. So this query, instead of table name, I'll have a query in the from clause. And these derived tables, they are not stored like our EMP or DBT table. They do not physically exist in the database. They are executed like queries. When you have aggregate function along with non-aggregate column, like for example, the one that we have seen, the first example, I want to know the name and salary. So we have a non-aggregate column along with the aggregate function, that is max of sal. Or when you have all, that is aggregate functions, expressions and groupable columns, then you should go for from clause query, or it is also called as derived table, or it is also called as inline view. Okay, but please remember one thing, that though it is called as table or view, it does not physically exist in your database. It is written and executed like a query. Okay, now let us understand it through one example, so that we will come to know when to go for a derived table. Okay, now please have a look at this requirement. I want to have, or I want to display names, jobs, salaries, and also I want to display average salary. That means AF. AF is what? Aggregate function. Also, I want to know the difference, that is raise with average salary of those employees who earn more than average salary in their own jobs. Fine.
Mhm.
Now, till now, how you were writing queries? You were like writing queries that, let's say, I'll make it simple first of all, and then we will see the complicated one. So, I want to display the average salaries. Just a minute. Okay. So, what it is giving me is, it is giving me manager's average salary. Okay, more salary for the job of any manager. Now, this thing or this query is overall manager. Okay, overall job we are talking about. Only one job across all the company. But my requirement is different. Okay, my requirement is that I want to find out I want to find out that the difference between the salaries with their own jobs. So what it should do is it should go to every record. So there are different steps that it has to do. The first step that it is supposed to do is, the first thing is go to record, right? The second thing is find job of that record, okay? And then third thing is compare value with the job of that record, okay? So this activity will be done for every record. You go to a particular record, then find the job of that record, then find the average salary for that particular job, and then compare the salary with that average salary. Like this is it has to do with every record. Are you getting my point?
Mm-hmm.
So this particular activity, ready-made table is not present for it. So we'll have to write a query for it in the from clause. So the set of records will be not coming from any table, it will be coming from a particular query. So what should be the query for it? So we will split the query in parts and then study it. Let me first write the query. Let's check it. Okay. Now here you can see that there is a join between two. Okay. Uh, Now I will only execute the inner part of the query so that we will understand what is this query all about. Right? So I'll take a new session. I'll, I'll create a new session.
One related question. So, in sheets could refer, or even workbooks could refer each other. In SQL, two different query, like you created two different instances, or maybe what
Sessions
sessions. So two different sessions can connect.
connect in the sense
They can refer each other.
they can refer each other as there is something called as temporary tables that we are going to study.
Mm-hmm.
Okay, so through temporary tables we can get the data, and unless and until one session commits the changes, they are not available to the other session. Okay,
Yeah.
so consider that this is user 1 and this is user 2. Fine. So I'm going to copy data from here and paste it here. So this is my query. Select job, average sal, group by job. Okay. So let's execute only this much part. What am I getting out of it? I'm getting the job and its average salary, right? Now, I do not have a table which contains this data, but I need this data for the execution of a query, right? So, I cannot create a new table just to execute, just to have this data. Why cannot I create a new table? Because this data keeps on changing. So I cannot have it in a table. So what do I do is I get it through a query, but these set of records I treat it as a table, derived table. Okay, so what it is giving me? It is giving me job wise average salary. Okay, so let us come back to this session. Now what you see here is in the from clause, if we are joining, how do we join in the from clause? We say like this, isn't it? From table 1 join table 2, isn't it? That's how we generally use a join. From EMP join DPT. That's how we do. But in this case, we are going to use from table 1 join it with. So this will be a physical table. Here the data will be coming from actual table, which will be joined with a query in which the data is coming from a set of records, treated as if it is a table. Okay. So let us understand this. Select for EMP table, we have given alias as B, sorry, as A. We have joined it with a derived table, which is this. And to this entire set of records, we have given alias as B. Okay. So B is nothing but the alias for the set of these records. Like a table name, we are using B. Okay. So for B, what do we have to display? I have to display from table EMP a dot name sal job, and then I'm saying b dot sal avg. What is this b dot sal avg? B is this record set, and what is this sal avg? It is alias given to the column from that table, that query I mean to say. Okay, so to sal avg we have given alias. So now I can say b dot sal avg. Okay, and then I want to have a difference between employee salary table minus b dot sal avg. So it is an expression that I'm using, and to this expression I have given alias as raise. Okay, and what is the joining condition? Outer query's job is matching with derived tables job. So whenever there is a job match, then I'm going to find out this query, and I want to know if at all A dot salary is more than B dot salary. Okay, so these are all the employees.
One question.
Huh.
So the inner query acts like if, am I right?
I lost your conversation.
So the inner query is, can you hear me?
Yes,
So select job, I'm inside, I'm on the line 2, which says from employee A inner join select job, comma, and then it will go to average salary as cell average from employee group by B. So this thing, average thing is the inner query.
yes,
And
subquery.
this thing creates a condition.
No, it doesn't create a condition. This thing gives you this job wise average salary.
Mm-hmm. Mm-hmm.
So it will give you a set of records, job wise average salary. That is why explicitly I executed this in another session. So that you
Got it,
will.
got it. So I was trying to understand if mm, this is like if this checks. I mean this is another question, maybe related or unrelated. Can we have if else kind of check in SQL queries?
Do you remember we have studied something called as case, when then.
Yeah, case when then. Yes, yes.
So that is something like if then else we can use.
Okay, got it. Thank you. Thank you.
Okay. So here what it is going to do is it is going to basically uh, get the job of the outer query and compare it with the inner query's job. If it is matching, then it is going to have a difference between the two. Getting it?
Yes.
So the inner query is basically giving me all this data, isn't it? These values. So what it is going to do is, suppose there is employee 1 with name A and his job is, let's say, clerk, and employee 2 with name B, his job is manager. 3 with C and his job is, let's say, analyst. Okay, and so this is, let's say, outer query, and inner query is having job wise average salary, that is 70, uh, analyst manager's salary suppose 800, and clerk's salary suppose 200, whatever. Fine. So this is my inner query, subquery, right? Now every time this query, let's say it goes to record 1, after going to record 1, it checks the clerk, the job. It checks the job clerk, and then for this clerk, from this record set, it will check the clerk's average salary. And is this salary more than this person's salary? If yes, then find the difference between the salaries. Similarly, it will go to now record 2. After going to record 2, it will take the job, which is manager. Then it will again go to the record set manager. Is it manager? No. Is it manager? Yes. So it will take the salary of average salary. This is what? Average salary. Take the average salary. Is it more than the salary of this person? If yes, then find the difference between the two. So every time it has to refer to the parent tables, each and every record. So the values are going to be known runtime only. Is it clear now?
Yes.
Great. Yes. Do you remember we have studied top n and top n percent?
Yes.
Hmm? So generally, how do we use it? We use it like select top three, let's say ename sal from employee, right? So this is how we use top 3 or top 3%, that kind, isn't it? So now we are going to use it here. I want to use top n analysis with derived tables. Okay, so how we can use it is to see first 3 highest salary records. Okay, now what is the difference here? Here, if I write a query, select top 3 salaries, I'm not sure that I'm going to get the highest salaries, right? It will give me first 3 records and fetch it for you, but I want the highest ones. Okay, so there is a difference between it. If I say select top 3 sal from EMP, what it is going to give me? 800, 1600 and 1250. These are not the highest salaries. These are the salaries of first 3 employees, right? So we need to modify this query and take help of the from clause or the derived table. Okay. So I'm going to say select E dot star. What is this E dot star? Star means all the columns, right? Now
Yes.
in the from clause, I'm having a query here. And what does this query do? It says select distinct top 3 salaries from employees ordered by SAL DESC. To this entire, the one that I'm highlighting, to this entire query, I have given an alias called as top 3. Okay, as if I'm giving name to this record set. So we can refer to this top 3 as a table name, like a table name. Okay. So I have created this record set. Now I am going to individually copy it and execute it. So we will understand what is the record set of it. What am I saying here? Select distinct top 3 salaries from employee and order by salary DESC. Fine. So when I'm saying order by salary DESC, that means I'll get salaries arranged from highest to lowest, right? And when I'm saying top 3, I'll get only 3 records. What is this distinct? What will happen if I do not use distinct?
There will be redundancy.
Let's say I'm cutting it. What do you see here? Record 2 and 3. See, there are two persons who are having same highest salary, 3,000. That should not happen, isn't it? We say, when I'm saying top 3 highest earners, that means they should be 3 persons with distinct salaries, right? So I don't want repetitive values. So I'm using distinct here. Now if I execute, this is what I get. 5,000, 3,000 and 2,975, right? So this becomes my from clause query record set. Now what I want? I want to know the salary records. I want to have the entire record of these person. Means this is this is giving me, sorry, this query, it gives me the highest salaries of 3 persons, but it only gives me highest salaries. I do not know the details of these persons, right? Their names, their jobs, their departments. Along with these salaries, I also want their details, their information. So for this, I'll have to use a subquery. Okay. So I will go for a from clause subquery here. So these are the persons who are earning some salaries like that. So as you can see, 5,000, 3,000, 2,975. Okay. So these are all these fellows who are earning the top 3 salaries in the company. And what is my joining condition? Top 3 dot sal is equal to E dot sal. That means inner set's salary I am matching with outer set's salary. And this order by is like how I want to display the salaries. That is 5,000 first and then 3,000. Okay. Is it fine?
Yes.
Okay. So this is called as derived tables. I'll just uh, stop sharing the screen. I want to look for a file and then I'll share it again. Okay.
Okay.
Okay, can you see the screen now?
Yes.
Okay, so the next topic that we are going to talk about is correlated subquery. Okay, so we have seen from cross subquery right now, and now we are going to talk about a correlated subquery. So, if you remember that there are two types of subqueries, that is simple subquery and correlated subquery. Now, what is the basic difference between the two is when I'm talking about a simple subquery, basically simple subquery it executes only once, giving a result to the outer query, right? And taking that result then multiple times the parent query executes. But in case of correlated subquery, the correlated subquery execute every time for the outer record or the outer query or parent queries each record. Fine. So let us have a look at this presentation. See, now this is about correlated subqueries. Now I thought I should give it to you in a form of presentation so that it will be, better to visualize rather than me telling you across just. I want to retrieve a supplier names for suppliers who supply part 1. There are two tables. One is supplier table. Okay. So as you can see here, there is a table called as supplier and there is another table called as shipment. Fine. Now I want to retrieve supplier names. That is, this is for I want to retrieve supplier names for suppliers who supply part 1. Now can you tell me part 1 is in which table?
Part number is in second table.
Right. It is in shipment table, isn't it? That is P1. P1 is in shipment table. So there are multiple customers or multiple suppliers who is for part 1. As you can see here, part 1 like that. Okay. So I want to know the names of the persons who supply part 1. Fine. Now, if I simply take a subquery and join it with this query, it is not going to give me, because if I use a normal query, then this inner query, it will execute only once, giving result to the outer query, right? Taking that result, then the outer query is going to get executed. But I cannot, expect this query to execute only once. So what is going to happen is, now in case of correlated subquery, first of all, it is going to provide the outer rows value to the inner query. Taking that value, it is going to check wherever there is S1. Why S1? Because this S1. It is going to provide supplier number S1 to check with part number 1. So every time it is going to check supply S1 with part number 1. Getting my point? So every time it provides a parent record to the inner query. The taking that parent records, then the inner query execute those many times. Now it is going to provide S2. For S2, it is going to check for the supplier part number P1. Again, For S2, it is going to check for part number P1, right? Are you getting my point?
Yes.
So every time the parent row is submitted to the child query, and taking that parent row, it is going to check whether the existence is there or not. So it is not like a regular subquery. Are you getting my point? It's a correlated subquery. Okay. What I want to display? I want to display supplier name, which is in the supplier table. Exist is an operator. It's a Boolean type of operator. It tells me whether it does not fetch any record. It just checks whether the record exists or not. So it is true or false type. Okay. Now, what is my parent? What is my subquery? The subquery is saying select shipment dot part number. That is, part number is a column from shipment table where supplier number is equal to shipment's supplier number. So I'm trying to match this supplier number with this supplier number, right? So as you can see, there are two blue color lines here. That is supplier 1 with P1 and supplier 2 with P1. So these are the two matches, right? And that is Acme and Holtz, right? How do you understand that it's a correlated subquery? That is the part, like if you look at a query, how you will come to know that it's a correlated subquery? Inside a subquery, please remember this. Inside a subquery, you will see a column which belongs to outer query. Do you see this? Supplier dot supplier number. This column is coming from where? This column is coming from the parent query, right? So in a correlated subquery, it there will be existence of a column of parent query inside a subquery. Okay. Now, as you can check here, so these two columns are there. How the execution takes place? First of all, first of all, this is what it makes it a correlated subquery, right? That means existence of parent column in the subquery. So how this query is going to get executed? The first thing is the parent query will send its value to the subquery. Taking that value, the subquery will execute for it. Again, for the next record, a new value will be sent to the subquery. So for every parent query, the subquery execute once. So imagine if there are 5 lakh records, 5 lakh times the new value will be sent to the subquery, and 5 lakh times the subquery will execute. Okay. The inner query is executed once for every row in the supplier table. That is the parent query. That is the value of supplier number passed to the subquery. That is this supplier number. Okay. Exists will check whether the record exists or not. Now this is a very helpful slide. Please carefully watch this slide. The starting point is the parent table. Okay, that is the supplier table. Now it will take the first, it will start from first record of the parent table, as you can see this arrow. Now when I'm saying what it did, it sent S1 to the nested query. that is supplier number was sent to the nested query from the parent table. Now it executed it, and then it finds that for this supplier S1 and S1 got matched and P1 is there. Fine. We have a requirement of P1. So S1 is present here. So what is the value? Yes. Exist test, it gives me yes. Right? So it is giving me a name, that is Acme. Right? So as you can see here, I am getting Acme. Okay. Now for next record, again the same entire procedure will be done. For S2, the S2 will be sent to the inner query, that is S2. So S2 came here. Now again it will check whether S2 is present. If yes, if it exists with a P1 part number, yes it exists, then that is the value of holds. So it will be displayed as holds, as you can see here. That is the value of holds, right? Now the next thing is S3. S3, is it present? No. S3 is present, but it does not present with part number 1, right? So it has to continue for S4 and S5 as well. So every time it will have to provide its number to the parent, from parent table to the subquery. Is it fine?
Yeah.
So what I'm trying to tell you is it gives a lot of load to the server. So for every record the subquery is executing. So these were the two topics that I wanted to discuss with you. That is called as derived tables and correlated subquery. Now we are going to go forward to something called as
One related question. So
Mhm.
just stay on this screen. Say for example, can you take to the same folder where all the topics of SQL are there?
Mhm.
So we see SQL, data types, aggregates, tables.
Everything from this is not in our scope. This is my general uh, course contents. So
Mhm.
whatever is in our scope, I choose from this.
Yeah, you shared the syllabus with me at the
Hmm.
first class, so probably that syllabus you're following.
Yes, yes,
Oh. No, my general question was this: where does SSIS and SS are these three things separate? SSIS, ASRS, and
definitely.
the basic SQL, or at some stage in this sequence they fit in?
Not at all. See,
Mhm.
basically there are two different things. When you install SQL Server,
Mhm.
there are two different things. See,
SQL Server.
what we are learning right now is database specific. Okay, that
Mhm.
is SQL, that is how to write queries and how to use programmability with the database, right? Now, then other than this, there is something called as integration services. Hmm? Then there is something else which is reporting services. Okay. Now what you are saying, that is SSIS, AS and RS. This is altogether a different track. It is called as a BI track. Okay. BI track is nothing but business intelligence track.
And
Wherein
what is the track we have covered?
this is what we are talking about right now is database. This hello?
Yes, is it DB developer?
Yes, what we are talking about right now is the developer track. That means how to interact with database server.
Mm-hmm.
So how to fetch data, create objects, write queries, and write programs for to work on those queries and database. Okay,
So this is not even
and
DB.
BI.
So
Sorry.
I cannot create a. We have not learned creating a DB.
No, we. That's what our focus is. Developer track. You know how to fetch data, how to work on data, and how to create objects, and how to write programs. Programming part we are yet to start. We have not done that.
Okay, okay, now I get. Okay. Once we so 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 at some stage I was doing this .NET thing, C sharp .NET thing, and on while doing the front end, we used to create classes, and classes used to we used to name DBO database objects and tables there,
Hmm.
and but those tables had to be created. Uh, those tables had to be created somewhere.
So that's how we have just seen how to create a table and all that.
Right, create table, we name that table.
Hmm.
So the front end person actually can refer to these tables and can store data from front end uh, windows and forms into these tables.
Basically, what happens is suppose you have a button on front end called as add record.
Yes.
So the data entry operator will click on add record. The moment he clicks on add record, a procedure to add record gets fired. And who has written that procedure? The developer has written that procedure. And the procedure inside that, it has insert statement.
Mm-hmm. Mm-hmm. And that is the program you are saying, which we are going to uh,
Yes, so we are
learn.
going to study how to create procedures.
Okay.
And
Okay,
that
got
form will have a button, and the button is associated with that procedure P1, and the procedure P1 has insert statement inside it.
okay, okay,
Okay.
okay, got it.
Hmm. Fine. Now we are going to talk about something called as CTE. It's a short form. Everybody calls it as CTE. And what is CTE? CTE is called as common table expressions. Okay. So let us first find. Okay. So 2005 significantly enhances the functionality. Sorry. So basically, what is the purpose of this CTA? Is to enhance the performance of a query. That is the bottom line. Okay. Now, the select statements with clause was introduced in 2005 SQL Server version, and it provides a new syntax. The purpose is to optimize query speed by eliminating redundant processing in complex queries. I think I have told you this before also. Whenever I execute a query, how does it get executed? It goes from client to the server as a request, isn't it?
Mm-hmm.
So, uh, and then that query will go to the server, and that query, when it gets executed, it undergoes few uh, stages of process. Like for example, it is called as parsing, binding, fetching, and execution.
Mm-hmm.
So what does it mean? That is associating, first of all, it has to check for the authenticity of the user. It has to check for the authenticity of the tables. It has to check for the correctness of the syntax. It has to also associate values of variables. It has to bind variables with the values. Then it has to execute the queries, and then it has to fetch those records and then give it to the client. Right. So every time you execute the query, may it be the same query, but every time it has to go to the server, do these all things, and it come back to you with the records. Right.
What did you say? Binding, parsing, binding.
Fetching, execution, like this.
Okay, got it. Thank you.
And so these such kind of activity, it involves a lot of IO traffic in it, from client to server, servers from server back to the client, like that, isn't it?
Yeah.
And uh, this reduces the what I can say, performance.
Mm-hmm.
So what we can do here is, there is something we can use that is called as CTE. How we use this common table expressions? We can use it using a with clause. Okay, so by using it, we can enhance the performance of a query. That is the bottom line. So the scenario is, suppose we have some kind of lengthy query, and which has got multiple references to a single subquery block. Processing subquery blocks with a lengthy query, that means the same query again and again, it will become very costly for the server, considering that number of records are huge. Okay, the with clause, formerly known as the subquery factoring clause, is part of SQL 99 standard. That's okay, don't bother about it. The clause precedes the select statement of a query, and it starts with the keyword called as with. Okay, the with is followed by a subquery definition and a label for that result set. Now, how do we use it? Okay, first of all, we will see without with, and then we will see with using with. So this is our normal sub. There is nothing new in this query. This we have been using multiple times. Okay. So this is our traditional subquery. What is a subquery? Let us understand. Select max of sal where department is 20. So if I execute only this much, what is it going to give me? 3000. That is, it is going to give me department 20's maximum salary, right? And then I'm checking who all is having, whose maximum salary is more than that of department 20's maximum salary, right? So if I execute this entire query, department 10, here I'm saying group by department, so it will find out department wise maximum salary, and then it will find out the department whose salary is more than the maximum salary of department 20. So 10 is having maximum salary more than 20's maximum salary. Fine. So this is our regular SQL query. There is nothing new so far. But then how we can improvise it, that we are going to see. Okay. In this query, there is a lot of performance overhead. Now, why is this saying, why they're saying that there is a performance overhead? So basically, maximum salary. There is an aggregate for maximum salary of department 20 is to be calculated. Once I know department 20 is maximum salary, then maximum salary is calculated, returned by subquery, and again by parent query to find out maximum salary of each department, right? So multiple times I have to find out the maximum salary. First it will find maximum salary for department 20, then it has to find out group by department 10, then it has to find out maximum salary for each group, and then it has to display the maximum salary for that group, right? So unnecessarily it is doing the same task again and again in the same query, right?
Mm-hmm.
So what we can do is we can use something called as a common table expression in this query. How do we write a common table expression? It begins with a keyword called as with, and we give a name to that common table expression. What name we have given here? We have given here a name called as summary. Okay, so how do we write? With summary as. Okay, and then we say department wise max of sal. To this we have given an alias because we need to refer to it, group by department. So what it is going to give me? Department wise maximum salary. Now every time I will not calculate maximum salary. This has been done only once. Next time in this query, I am going to only refer to summary. Okay. So I'm going to say select department number, highest salary from summary, where highest. What is this highest?
Where highest, select highest from summary where department number is 20. In this
But
department,
is it a column name?
select department number highest. Select department number max cell as highest. Is it alias? Is alias?
That's what I said. We are going to need it. So for this max sal from the common table expression, we have given this alias name. And this we are referring here. So in short, it is where max of sal, right? Where highest is more than the summary value, right? So
Mm-hmm.
how is it modified here? So I will just I'll just have to say now highest whatever from what summary. So every time I do not have to have that set. That set is already there with me. Getting, of course, result is not going to change, but there is a big performance benefit over it. Fine. So this summary is what? It's a common table like name given to the CTE. Okay. And what is my CTE? My CTE is nothing but department wise highest salary. So this calculation is going to be done only once. And I'm going to say select department number, comma highest. Highest means what? Max of sal. I'm not going to calculate it again and again. From summary. Am I using a table name here? I'm not saying from EMP. I'm saying from summary. Means I'm talking about this set of records. Right? Where highest is greater than, select highest from summary where department is 20. Is it okay now?
Yeah.
See, the advantage is, suppose after this, suppose instead of this, I was using something called as, suppose there was a union. Do you remember we have studied set operators?
Yeah.
Okay. Suppose there was a union, and in union also I needed max of sal group by something, group by DPTNO. And then after that I have had intersect again. In intersect, suppose also I needed group by max of sal. Are you getting my point? So if it is a very lengthy query in which this set of records I am requiring every now and then, why to calculate and uh, make the query more lengthy? So every time, instead of doing the same thing again and again, I would rather say summary. So my query is now compact and performing better than the previous method. Okay, so in the beginning only I'll have to specify with CTE name as and whatever you query you want to associate with it with clause. And then you can use it at multiple places in that query. Okay. Yeah, a temporary table summary, it gets created which does not which does the job of finding department wise highest salaries. Using this summary table, then simply max of sal of department 20 is filtered. Here aggregation is done only once. This is the best part. So every time when you come across max of sal, every time it is not going to find out the maximum salary runtime. It has been already done once and used it multiple places. Wherever you see summary, it knows which value it has to fetch. Getting it?
Mm.
Now there is a proof here. I'm going to use the old method, execute. So this is session 1. Okay. Do you know about commenting?
Yes.
Single line comment and multi-line comment. So I'm using here a single line comment, session 1. Okay. And maybe this is my another session. This is session 2. Okay. So that we will understand what is going on. I'm executing this query, and in this query I'm going to execute this query, and you will see the statistics of that query. Fine. Now there are many things, even I don't know all of it. It tells you the execution plan, how the average time taken for it, etc., etc. Number of server round trips. There is one round trip here. Then rows returned, how many rows returned, etc., etc. Now see the time statistics. Uh, Client processing time is 11. total execution time 11, and wait time 0. This is when I am using a regular query. Okay. Now I am going to go here and I am going to use a CTE. That is the same query with common table expression, and I am going to execute it.
Mhm.
Now let us understand the client statistics. See, it's not going to make much difference because our data is small right now. Please understand that. It will show huge difference if you have large number of data and large number of aggregate functions on it. Okay, but still you can check that it is reduced time. Okay, so performance is always better because this activity will not be done multiple times. Even though this code is coming multiple times in my query, the activity will be done only once with the common table expression. Okay,
Mhm.
now these common table expressions, they can be used in the DMLs also. See, uh, A is the common table expression. I'm saying select something union with something. Okay, and what we have given here is A as this much. So this entire query is prefixed with A, and I'm unioning it with something called as another query B. Please remember one thing, that order by clause cannot be used in CTE. Okay, so if I'm using order by clause in common table expression, it will not work because I'm not displaying the data of common table expression. It is going to be used in some query which will have a order by clause. So do not use order by clause in common table expression. Now you can have multiple CTEs in a query. For example, there is a CTE1, there is CTE2, and in the final query, I am using CTE1 joined with CTE2. So it's such a convenient way of using a CTE. Instead of having a lengthy query, I am creating this record set only once and then I'm using it multiple times in that query. Right? Are you understanding this?
Yes.
So that was all about common table expressions. Fine.
Mhm.
So we will take a break here and
Okay.
then we will continue after. Huh? We will
Yes.
continue after break. Right? What
Okay.
I'm going to do is I will not disconnect.
Makes sense. Makes sense.
I I will mute here from my side so that we will not have to rejoin the meeting.
Yes.
Okay,
Good idea.
and I'll pause the recording for the time being, and then
Okay.
I'll start recording again.
Okay. Okay.
Fine? Yes.
Oh,
So after how much time we'll meet?
you tell
20
me.
minutes?
Okay.
Fine. Okay.
This conference will now be recorded.
Okay. So the topic that we are now going to discuss is called as exception handling. It is very much important to handle a particular error. What will happen if the error is not handled? The error, if not handled, will throw an exception and will stop the execution of the program abruptly. And then the further lines of code following that error will not be executed at all. So to avoid such scenarios, what we should do is we should properly handle the error and then avoid the further execution of error being stopped, right? So there are different methods. Every database had different methods of handling errors. Like in Oracle, there is a separate what you can say part of the block called as exception, and then we write different handlers for different errors. In SQL Server, the error handling is done using try catch block, like we have it in Java or C++, right? So how these errors are handled? Now there is a variable. Uh, you're aware of the concept of variables, right? We store variables or we use variables to store values temporarily, right? So in SQL Server, there is a provision that is at the rate. To declare a variable, we use at the rate, and to declare a global variable, we use double at the rate. Okay, so this at the rate error, this is used sorry, this is used to evaluate the error number. For example, see, I'm going to use select 1 divided by 0. Obviously this is an error scenario. I'm going to say select 1 divided by 0. So this is an error situation. So I'm going to execute it now. What happened here is it is giving me an error along with some kind of error message, right? So if at all there was, let's say after this there was 1,000 lines of code, there is a problem for this code because it is based on the output of this query, right? Now to avoid such scenarios, what we do is we handle this error. Now I don't want this getting statistics. What we are going to do here is we are going to execute this block together. It's a global variable. Can you see? When I point on it, it becomes, it tells you what is this at the rate error. So single at the rate is a local variable and double at the rate variable name, it becomes a global variable, right? Now, can you please think and tell me if I individually execute only this much, fine, what will be the answer? Right now, I have executed select statement, isn't it? And it is the error that I have got getting 8134. So will it print 8134? What is it doing? It is printing 8134 because the global variable right now is having the value of that error, that is 10. So I may execute it as a batch together. Okay. So what does it say? One row is affected and then no column it is printing. So I'm getting two different results. One is for no column and the other one is 8134. That is for the second select statement. Okay. Is it clear?
Yeah.
How to use it? How to use this for handling error? Is if at all, is there any error, then I can check whether to handle it. For example, I'm not going to let's say this is a phrase session that I'm using. This is session 2. Okay. So for this new session, right now, there is no error, no error of nothing query. Okay. Now I'm going to say select @ error, right? So now if I say select @ error, what will it show? 0. Getting my point? That means two different session, they are maintaining two different values for it. This global variable is having the value across multiple blocks. Fine. And this session is right now there is no error situation. So what is the value? The default value, it is 0. Isn't it? So how you can use it in is like in a program I may say select 1/0 if @ is not equal to 0. This is a not equal to symbol. Then I want to print the value. That means if there is some kind of error, print it. Okay. Don't bother about how this is written. We are going to see the syntax of if later on. Okay. So just understand how it is written. I am saying this entire batch I am going to execute. Trying to catch the error in this case actually ends up resetting it. In the select statement, it returns 0 rather than 8134 because the if statement did not throw an exception. Are you getting my point? So when I'm
Yeah.
executing this, actually this one it returns what? It returns 8134, right? But this particular statement, it does not have any error, right? 8134. Right now, what is the value of @ error? If I execute only this much, the value is 8134, which is obviously what? Not 0. So it will be 8134. Then it will go inside the if statement. The if statement does not have any error, and that is why the value returned is not 8134, but it is what? 0. Because here the value is 8134 and this value gets resetted here to 0. Getting my point now?
Mm-hmm.
If statement is not having any error, so @ error gets reset to 0.
Mm-hmm.
That is the behavior. In addition to the fact that exceptions reset after does @ error does actually handle the exception. It only reports it. The exception is still sent back. Now we are going to see how to use try catch block. The term catch is of special importance here. When try catch is used, the exception is not returned to the client. It is caught within the scope. Till now what is happening here is it is see this is how it is working. This particular exception is raised and it is returned to the client. Okay. Now instead of returning the exception or throwing the exception to the client, we are going to catch it and handle it. Okay. So how we are going to use it? We are going to use a try catch block for it. And how we use a try catch block is it starts with begin try and it ends with end try. Whenever error occurs in this begin and end, it gets caught in the catch block, and the catch block is begin catch and end catch, right? So this is a hello world type of example that we are going to perform here. Let's have a look at this code. Is there error at this point? There is no error, right? Is there error at this point? There is no error. Is there error at this point?
Looks like yes.
Has to be, isn't it? So this is the culprit. So the error is at this point. Now, if I execute only this much as a batch, okay, then what will be the output if I execute only these 3 lines of code?
The error will be caught.
No, what will it display? What will be the output of this batch? I don't bother about try catch block. I am just going to execute these 3 select statements. See, one row is affected, then the error is thrown to the client, and then one row is affected. So if you see the results, this is what you get. You get 1 as printed, the first select statement, then you do not get any output in the result set, and then you get 3. So what it does is it throws the message to the client and it raises the error, right? So they act as 3 independent select statements. That is not one block, or it is not one program, right? Now what I'm going to do is, instead of you firing them as 3 independent select statements or as a batch, we are going to put them in a try catch block. Okay, so now let us see the output. I'm going to execute this entire try catch block. Now what do you see here is, see, the error is not thrown to the client, but it is being handled now. As you can see, 1 row is affected, 0 row is affected, and 1 row is affected again. Sorry. And the results you can see here, error is 1. Then for this we get error caught. Error caught, that means it is coming to the try catch block. Do you see 3 here? Do you see number 3 here as an output?
No.
No, you will not see that. So what is the behavior? How did it behave? It first printed 1, as you can see. Then it went to the next line. The error is at this point, right? So the exception was raised and the control went to the catch block. Getting my point? And the error was caught here and it is printing the line error caught. And it is a successful execution of the program. Now the next lines of codes will get printed after it. It will not terminate. So I can write anything inside. I can even give a call to a procedure something, or I can write rollback statements here. Is it fine?
Mhm. Yes.
So it is not abruptly ending the program. It is handling the error and it is successfully executing the program. So the message window itself tells you that. And of course the results, as you can see, it is not It is printing 1, it is going to second line, it is not printing 3, but yes, the control is going to the catch block and the error is getting handled here. And it is printing that message, it's a debugger line.
Mm-hmm.
So what we are learning right now is the topic that we are learning right now is exceptions, and we are talking about a global variable that is @ error, right? And then now we are talking about try catch. Whenever we run this batch, no exception is reported. Instead, the error caught message is delivered. Now, your TSQL code does not have to send back any kind of specific message to the catch block. Any valid TSQL can be used so that you can log the report. Sorry. There are two functions in SQL Server. They are called as error message and error number. Now, what are these functions? You know that a function always returns a value, isn't it? So, in SQL Server, error message, it returns a message associated with the error, and error number, it reports the error number associated with the error. So if you want to check that whenever such and such error number is there, then you do this much. Whenever such and such error number is there, then you do this much. That means right now we are coming across which error? We are coming across this error, that is 8134, I guess, isn't it? Yes, 8134. So now we know that if the error number is 8134, that means it's a divided by 0 error, right? So the function error number, it may tell you that the error number is 8134. If error number gives you 8134, then you divide, instead of 0, you divide by 100 or you divide by 10. So programmatically, we can make changes in our code depending upon the error that is coming. Isn't it?
Yes.
So, for example, see, this is error message, error number, error line. It also tells you at what line the error is and the severity of the error. Okay. So we will execute this code. Simple. In the begin try and end try, I have only one sentence, that is select 1 upon 0. Right? And what all things we are catching? We are catching the values of these functions. These are all built-in functions. Okay, we have not created them. So what do you see here? Obviously, it's a successful execution of the program, as you can see. So right now, no values are written, and what you can see is the first one is error message. So what error message is associated with this error? Divide by 0. This is the error number. The column name, line on 1, that is, it was a first line. So line number, and this is status. Status is severity. The last one is severity. Now, depending upon the severity of the error, the functionality changes. Okay, so let us understand what is this. Okay, there is a table called as funds. Okay, and the table has a column called as amount. Can you tell me what is this?
It's checking if amount is greater than 0.
What is it called as?
Check amount greater than 0. But there is no try, so can it be called as a try check block or check amount greater than 0? It's a condition.
We are creating a table. Do you remember
Hmm.
we used create table command?
Yeah.
It's a constraint that we have used, check constraint.
Hmm.
We use different constraints like primary key, foreign key, check, not null, unique. So
Hmm.
we created a table here called as funds, which has a column amount, and the amount column has a constraint called as check. Okay. And what is my check constraint? That the amount should be greater than 0. That is my constraint. Okay. And now I'm going to insert two records inside it. What records I'm going to insert? Don't bother about what is this begin transaction and end transaction. That I'll tell you later on. We are yet to study the topic of transactions. Okay. Now I'm going to insert two records. We have studied insert, update, delete. Okay, the DML part. One record that I'm going to insert is called as 10. Other record that I'm going to insert is -1. Now, there is no error or no invalid data for record 1, right? So 10 is obviously greater than 0, so it should accept it. But for the next insert, I am inserting value -1, which is not greater than 0. Okay, so let us execute this block and see what happens. Fine, I'm going to execute this block. What happens here is it says one row affected, and then it is throwing an error, and this is the error message level 16. Okay, now what is this level 16 that we will talk? Okay. Now I'm going to say select star from funds, that is my table name. So let us check whether the rows are inserted in my table or not. So which rows got inserted and which rows did not get inserted? The first record got inserted. Then for the second record, there was an error which was raised and given to the calling environment, and the row did not get inserted, right? So as you can see here, the table funds is created, which includes a check constraint. So this discussion we have already done. I've told you all the values or no values should be inserted. However, even though an exception occurs due to violation of check constraint, the transaction is committed and one value remains in the table. Now, this is actually not correct. Getting my point? That means what happens here is it may be that there is one insert statement and then there is one another insert statement, right? If at all, imagine that this insert statement has an impact on some other inserts or update. It should be either both of them should be committed or none of them should be committed, right? But here, when I'm saying commit transaction, what is happening here is there is a partial commission, right? The one which was having error did not get committed. The one without error got committed. So there is a half transaction done here, not full transaction. So it should be either complete transaction done or complete transaction undone. Getting my point?
Mhm.
Now we are going to implement a try catch block here. Fine. So now let us see what happens. I'm going to do it in another session, that is session 2. Now what changes we are going to make to this code is, here I am going to have a try catch block, that is, how does a try catch block starts? Begin try, end try, and to handle the error we use begin catch and end catch, right? So inside begin try and the same code that we used, insert 10 and insert -1. Okay, so the code remains the same, but now it is in try catch block. And what I'm catching, whenever the error is at this point, right? So what I'm going to do is I'm going to say rollback. So rollback does what?
To roll back the transaction.
It undo. It brings the data to its original state, right?
Mhm.
So now I'm going to execute this block. What do you see here? Look at the first type. Here we get messages which are, you know, one rows affected, 0 rows affected. Now I'm going to say select star from funds. Fine. So it is not throwing any type of error, but it is handling the error. Getting?
Mhm.
I could have
Mhm.
written some kind of statement here just to check whether the error is getting handled, or a debugger line type. Okay, that I could have done. So now it is not throwing, but it is saying rollback. So the statement which is not correct is being rolled back, and the statement which is having a particular value is kept. I'll first say delete from funds. So right now there is nothing inside funds, and then I'm going to execute this block, right? Now the program has successfully executed. And when I see the table contents, when I see the table contents, what do you get here? Do you see any amount? No.
No.
Did you understand the difference
Yes.
between first demo and second demo?
Yeah.
Okay. So in the first demo, it was without try catch block. And what it was doing is I executed only this much, the one that is highlighted. So it was a parcel transaction, isn't it? Which is against the rule of
Mhm.
RDBMS. A transaction has to be either completely successful or completely unsuccessful. There should not be any intermediate level,
Right.
isn't it? So suppose I'm saying insert into funds, or insert into funds values 4. right? What will happen if I execute only this much? I'm going to copy it. I will delete first everything from funds. Delete from funds. Okay. So right now the table is empty, right? 0 rows affected. Now I'm going to, so there is no error, there is error, and there is no error again, isn't it?
Yeah.
Execute.
Yes.
Right? Now tell me what will happen. Select star from funds. Execute. It is saying 10 and 4. Fine. So is it a correct way of handling a transaction?
Yes.
Imagine that this line is dependent upon this line. Then what would have happened? Suppose this line is uh, depositing. That means some kind of credit. Okay, I am crediting, let's say 500 rupees here, and after the credit is successful, I am withdrawing. I am withdrawing, let's say 300 from here. Okay, so this line does not have error, but this line has error. So what happens to this line then? Are you getting my point? So if
Mm.
this line has error, then the following statements which are dependent upon this line may be in trouble, right? So what I need to do is I need to handle it properly, right? So instead of just keeping the transaction and letting the error, throwing it to the calling environment, I would rather handle it and say rollback. So none of the transactions will be successful in this case. So I will put them in try catch block. And now if I say select star from, first of all, if there are any earlier records, I'll have to delete them. And then I will have to execute this batch. When I'm saying batch means set of records or set of statements. Okay. And now if I check this, there will be no records, which is a correct way of handling a transaction. Are you getting my point?
Yeah.
So even though there is no error with 10 or 4, still it will be rollback because there may be the insert statement may be dependent upon the one which has error. So this is how you can
Mm-hmm.
handle that exception, right? Okay. Uh, Look at this code, the one in front of you. Think and tell me
Yeah.
what will be the output of this block.
Can't say.
Will it print
One
A?
is wrong. Print A. I think it should.
Will it print 1 by 0?
No.
What about B and
Or
C?
it's the other way. No.
What about D?
Can't say.
I'm going to print only this much. Okay, first.
And try. We can try print. So print is also there in SQL.
That is different. That's a environment command.
It's print A, print 1 by O. Print is there in SQL, right?
Yeah, it's an environment command. It's not a part of query. It's a command. So what do you see here? You get A, then you get an error. So it printed the error, right? And then it is
Mm-hmm.
printing B and C, isn't it?
Mm-hmm. Mm-hmm.
Now we are going to handle this error. So ideally, what should happen that whenever the error occurs at this point, the statements after that should not get executed, isn't it?
Mm-hmm.
Because the sequence of statement, they may be B and C, they may be dependent on this line, right? So is there any
Mm-hmm.
point executing these two statements? No. So what we should do ideally is we should handle the error. So I'll put it in begin try, end try, and then I'll catch. So whenever the error occurs here, the control will go to the catch block. The execution stops. See, you take any database, the behavior of the execution is always same. Whenever the error occurs, the control stops at that point and then the error is thrown. Now it's up to the programmer whether the programmer wants to handle the error or he wants to propagate the error, right? So now we are going to handle the error. So it should not be illegal execution of the program. Now let us see what happens. This is successful execution of the program. Okay. Now, is there any error at this point?
1 by 0?
No, the one that I have highlighted. Is there any error at this point?
No.
No. That is why if you see the output, A is printed as it is. The error is on the next line, right? So the execution of the program, it stopped here. Where did the control go? It is trying to now handle the error, right? So the control went to the catch. And what is written inside catch is print D. So what it is doing? It is printing D and then it comes out of that block,
Mm-hmm.
right? So the output of this entire batch is it will print A, then it will go here, the error occurs here, the control goes to the catch block and then it prints D and then stops the execution. Please remember one thing, it will never take the control back to B and C.
Mm-hmm.
Okay, is it fine?
Yeah.
So there are many more things to be talked about here right now. So what What do you think we should do?
Next class.